Let me give you a graphical representation of one-sided test, two-sided test, and significance level. Before we start, you have to know that the sign of the alternative hypothesis, HA, decides the side of the test. So when you decide the side, one side, two side, significance level, so one side can be left side, right side. These are all depend on the sign of HA. And then the significance level alpha has another name. I call that rejection region. Let's take a look at the first graph. So the first graph, I have HA that mu is less than mu naught. So mu naught is a proposed population mean. So mu naught, we don't know whether that is true or false yet, so that is a proposed mean. We are trying to test the mu naught, so that's why we don't call that a mu, we call that mu naught at this point. So the naught means we are trying to test that. Is that true or false? We don't know that yet. And then how do you know that the first graph is a left side? How do you know that less than is a left side? Look at the graph. In that bell curve, we have 0 in the middle because that is standard normal. So we have 0 in the middle. Still remember the number line. We have 0 in the middle, negative on the left, positive on the right. Again, we have 0 in the middle. Just think about a number line. If you don't know what number line is, you should look it up right now. You make it to this point, you should know what a number line is. So number line, we have 0 in the middle, we call it the origin. We have positive numbers on the right and negative numbers on the left. So that means as you move to the right side, the numbers are positive and they are getting bigger and bigger. As you move to the left, the number are getting smaller and smaller and they are all negative. So we have mu less than mu naught. The less than means a left side. So what is on the left side? The alpha is on the left side. The alpha has two names. Usually people call this significance level, and then another name is rejection region. And then if I let alpha equals to 0.05, in this case the 0.05 is it is on the left side. So how do you find the corresponding C? Because every time you put some area under the curve, there must be a corresponding C value, right? So since you know the area, you want to find the corresponding C. That will be an inverse normal question, inverse normal distribution. So you go to your calculator and then you go to inverse norm. Where do you find the inverse norm? You press the second and then you press the vars. So you press the second key, usually that is in blue or yellow, and then you press the vars. The vars is right next to clear. So you go to second and then you press vars and then you will see inverse norm. You input the left side area 0.05, the mean is equals to 0, the standard deviation is equals to 1 because they are standard normal, and then you can get that Z is equals to negative 1.645. So that is the alpha on the left side, the corresponding C value on the left side. If you use a greater than in HA, so that will be the right side. So right side means you have the Z on the right hand side, and then you have the alpha on the right hand side. So that is the picture right in the middle. How about two sides? So for two sides, if you use a not equal, mu naught equals to mu naught, so that will be a two-sided test. So you already know that alpha is 0.05. So since that is a two-sided, you have to divide the alpha into two pieces. So 0.05 you divide it by 2, so you have 0.025, one piece on the left and then one piece on the right. So in this case, you have to find another Z. So I call that Z1 and Z2, Z1 on the left and Z2 on the right. You still use inverse norm, so you go to second vars, inverse norm, you put the area in there and then followed by 0.1, so you have negative 1.960. You always get a negative because the calculator assume that the area that you input is on the left side. So you have one on the left, one on the right because the graph is symmetrical. So you have a negative 1.960 on the left and a positive 1.960 on the right. So again, the sign of HA determines left, right, or two-sided. Do you put equal in HA? The answer is no. Think about this. If you put an equal, is that left, right, or both? We don't know, right? So that's why never put equal in HA. All right, so less than you put the rejection region, you put the alpha on the left. Greater than, you put the rejection region, you put the alpha on the right. Not equal, you cut the alpha into two pieces, half on the left, half on the right. How about the p-value? So the p-value is the probability value of a test. So for example, we are following a Z procedure. You read the problem statement, you obtain the X bar, the mu naught, the sigma, and the n straight from the problem statement. So that is given. And then the next thing is you plug in the X bar, the mu naught, the sigma, and the n to the formula, and you obtain negative 1.02 for the Z value, just for example. Okay, so don't worry about what those four values are. You plug it in, you get negative 1.42. And then we have a left side, right side, and a two side. So I forgot to put that in here. So let me just add this back. So this is left side. The first one is the left side. The second one is right side. And then the last one is two side. So left side, right side, and this one is two side. Okay, so for left side, you have area. So if you look at my graph, you have area. The area is 0.1151. How do you get that? So the area 0.1151 is the p-value. So you have negative 1.2, and that is under the graph you have negative 1.2. How do you get the area? The area is p-value. So do you see the area equals to 0.1151? That is the p-value. How do you find this p-value? I know that the sign is less than. That means left side. So that means after you cut the negative 1.2, the area must be on the left side of the cut. So you have to use normal CDF. Where do you find normal CDF? You go to second, you press the second key, and then you press was. Was is right next to clear and then right above the tangent key. And then you find normal CDF. So first you input the lower limit negative infinity, and then the positive limit negative 1.2, and then 0, 1, because that is standard normal. Mean is equals to 0, standard deviation is equals to 1, and then you get 0.1151. That is called the p-value of the test. What about right side? Right side means you have the area on the right hand side of the negative 1.2. So if you look at my notes carefully, I missed the negative sign. So let me just add that back. So Z is equals to negative. Z is equals to negative 1.2, right? Just fix that. And then you have the area on the right hand side of negative 1.2. So this area is supposed to be big. And then there are two ways to do it. Either you take 1, subtract the left area, you take 1 minus 11.51, or you use another normal CDF command. So you go to second vars on your calculator, and then you choose normal CDF. The left limit is negative 1.2. The right limit is positive infinity because you go all the way to the right. Mean is 0. Standard deviation is 1. You get 0.9949. So that is the area if the test is a right-sided test. How do you decide right, left, or both? The answer is you check out the sign of HA. So we just discussed the left side and the right side. And then how about two-sided? So two-sided mu is not equals to mu naught. Then this is a two-sided test. So how does that affect the p-value? So first of all, we have a negative 1.2 on the left and a positive 1.2 on the right. But that gives me two areas. One on the left, one on the right. They are both 0.1151. For a two-sided test, the final p-value, you have to add them up. You have to take the 0.1151 multiplied by 2. So the p-value of the two-sided test is 0.2302. You have to multiply by 2 because you have one piece on the left, one piece on the right. Add them up. The p-value of the two-sided test is 0.2302. This is all depends on the sign of HA. All right. Negative less than left, greater than right, not equal two side. Alright, so that is the end of this video. In the next video, which is extremely important, I will combine the rejection region, which is the significance level, and the p-value on the same graph to show you how to use the significance level and the p-value to decide whether you reject or fail to reject H0 by comparing the Z value. There are two ways to do it. So based on everything I said right here, I show you how to calculate the z and the p-value. Do you need to do this math manually? If you are using your calculator to answer each hypothesis test question, there is no need to compute anything by hand. The calculator will do everything for you. Of course, in the following videos, I will show you how to use calculator to get everything. But before we get into that, I also want to show you, other than using p-value to make a decision, how do you use the z value, in this case the negative 1.2, to make a decision. What kind of decision? Whether you want to reject or fail to reject H0. I will do that in the next video. Alright, so if you think this video is helpful, my instruction is clear, give me a like, subscribe, share the video for me. See you all in the next one. Signing out for now.